Hello and welcome to Chapter 4, Implementing Firewall Technology. So with this, we are going to start learning about how to set up a firewall. So first we'll really discuss the ACLs. Most of you should be familiar with the access control list that we've discussed in our previous Cisco classes. But here we'll get into a little bit more details and we'll talk about the zone-based policy firewalls as well towards the end, which is a little bit easier for configuration and we'll see how that works. But we'll get to that towards the end later on. Okay, let's get started. When we talk about the access lists, there are two different types of access lists, as we have already known. There is the regular standard and the extended IP access lists for IPv4, and then we'll also look at the IPv6, which is pretty much similar. When it comes to access lists, I want you to think of firewalls in general as like a security guard on the front gate, and they'll be able to inspect packets that are either coming into the gate or leaving the gate. So the security guard will have a list, and on that list there'll be a whole bunch of entries in that list, and every packet that comes in, he'll look at the list to see if there's a match. And if there is a match, then the security guard will take action. And the action is either permit the packet to go through or blocking it, denying it from going through. That's the idea behind what a firewall is. It's either to deny or permit packets from going in or out of the router based on the entries that are listed in the list. Okay, so here is, for example, a serial port on the router. In, by the way, means into the router. Out means out of the router. Has nothing, or in means into the router here. Out means going out to the internet. For this router one, in means into the router. Out means going out to the LAN. Has nothing to do with in the LAN, going into the LAN. It's not, so if you want something going into the LAN, want to block something from going into the LAN, you have to put the access list and tell the security guard you apply it to the interface going out of the router. You say out, not in, thinking that it's in the LAN. All right. With access lists, you can create for the standard list, which we'll discuss in a few minutes exactly what the standard list is. What does it match? Try to inspect. It has numbers between 1 and 99. That means you can create up to 99 access lists. You know, access list number 1, number 2, number 3. It has all the entries that are in it. If you run out of these numbers, you can go and use 1300 to 1999. For the extended list, the number should be between 100 and 199. And if you run out of that, then you'll use 2000 to 2699. In most cases, you never even need to go beyond the 99. Those extra access list ranges are hardly ever used. And probably a good idea not even to use numbers, use the named access list, which we'll discuss in a few minutes. Okay, so here are an example or the syntax for writing the standard, extended, and the named access list. So let's take a look at each one of them. I like to look at them as an example without just looking at because sometimes you may get a little bit confused when you are writing the access list just by looking at the syntax. Okay, so here's a typical access list that is, let me just go back. You know what? They don't show us an example, so I'll take it right out of my notes. So, and the notes that I put in here. So here's an example of the access list, standard access list. And what that means, for example, when you say access dash list, if you're going to write an access list, a standard access list, you should start with the command access dash list, and then you put the number. That number goes between 1 and 99. And then you write the command after it, either permit or deny. And here you write down for example, the subnet that you want to deny. In this case, it's 192.168.10.128. This is the wildcard, which is the inverse of the subnet mask address. So this access list, this one entry that says permit 192.168.10.128 with 000.127. This is one entry in access list number 10. If that's the only entry in the access list, anything below it, by default, it is an implicit deny. So there's only one entry that's going to permit this. So you created a list called list number 10, and it has one entry. We're going to permit the subnet 192.168.10.128/25. That's what this means. Now, we have not applied it. So if you need to apply it, what you do is, because it's on a physical interface, you go in and you type in INTFA0/0 because you want to apply it to the fast Ethernet of the router. And then you say IP access group. And in this case, it will be number 10 instead of a name. And you say out, leaving the interface. Out means most likely it's going into the LAN, right? So remember, standard list, they only inspect the source IP address. So this is the source IP address of who you're trying to reach. Okay. Extended list gives you a little bit more detailed. Extended list, the way to do it is you type in access list, again, access dash list, then the number between 1 and 199. So I chose 100. Then you write in the command permit or deny. Then you have choices of either what layer 4 protocol, TCP or UDP, or even ISCMP, depending on what protocol you're trying to either permit or deny, because now you're being a little more specific. So you have to type in this case, we're going to do TCP because I want to permit port 80. That's what this means. So I'm saying on access list 100, the first entry should be to permit the TCP protocol. This is the source address, where they're coming from, right? With its wildcard, and I'm trying to permit them to reach this host. So you can write host and the actual this, let's say it's dot. This is not a complete number. Let's say .3, right? So this is the actual host. And equal 80. So what I'm saying right in this entry is anybody that is coming from the source, from this subnet, trying to reach this server, specific server 172.16.100.3, and they're trying on that host 172.16.100.3, they're trying to reach HTTP, then permit them. That's what that says. Okay. Again, there's an implicit deny on it. Implicit deny at the end of this, and at the end of this access list 100. Here's another example. Access list 200. I want to deny TCP any from any place coming into any source to any destination, and they're trying to do 443 and the word established. If you write the word established, it means that if the connection was not initiated from inside, I want it to be denied. Okay, so that's very good. This is a very powerful command. This is what stateful firewalling is, keeping track of the state of the connection. So for example, if you are in the building and you initiated a connection to HTTPS tdbank.com. So when you leave the building, at your serial port on the outside, it's going to check and make sure that they'll say, okay, you're going to TD Bank. They'll take note of that. They'll take note of your connection, send you out to TD Bank, and when TD Bank sends information back to you, it's going to allow you because you're trying to reach 443 using HTTPS to TD Bank. And they'll say, oh, we have to be established. Anybody coming in from outside using this port 443, they have to be established. So let's say, all right, did anybody connect to you to DB Bank? If you say yes, then you'll allow them in. This is to prevent anybody from outside that initiated a connection 443 coming in. And if the connection was not initiated from outside, because that means it's not established, it would be blocked, right? By the way, the established command only for TCP protocol. So if you have a UDP protocol, you won't be able to use the established command. But there's another set of ACLs that allows you to do something similar to this called the complex ACLs, which we do cover in the earlier session, that allows us to do something similar to established for all the other protocols, the UDP, the ICMPs. Okay? Here's another command that you can use, another entry in access list, let's say 100. You want to permit ICMP, the protocol, and I want to permit this host. So by the way, when you write the word host and the exact IP address, that means you specifically one host, not a group, not a subnet. You want this host going to this subnet. Echo means ping. So you're allowing this guy to ping anybody in this subnet, right? All right. Now, instead of using these numbers, it is best to use a named list. So the best way to do it, so it's easier to refer to an access list when it has a name instead of a number. So I'll say, and you start creating a named access list by typing the command IP. You have to start with the word IP, access dash list, and either you need to choose standard or extended. So in this case, I chose standard, space, and then you give it the name. And then you start writing your entries. In this case, I want to deny this host from doing anything, going anywhere. Here's another list this is a standard list. That means the entry has to adhere to the standard list criteria, which means only inspect the source IP address. In this extended named access list, list number 2, I'm trying to permit this subnet going to any subnet or any host doing 80, port 80, which is HTTP. By the way, you could have wrote equal, that's what the EQ is, HTTP instead of the keyword HTTP instead of the number 80. Applying the ACLs on the interface, you just go to the interface and then type in either in and out like we've discussed earlier. All right. All right. Some guidelines. Here are some guidelines that you should follow when it comes to access lists. Place a standard access list close to the destination. So if you have a source access list that you're typing, such as this, after you're done, you have to place it close to the source, which is probably a good idea. I'm sorry, not close to the source. What did I say? Close to the destination. Because if you make it close to the source, it'll never be able to leave. When you place it close to the destination, so you can travel across the network, and only when you get to the destination, because he has the source address, it'll be able to be either blocked or permitted. If you're creating an extended list, you check him out before he leaves at the source. We're very close to the source. So the very first thing you always should take a look at when you are creating access lists is to decide, is this going to be a standard list that I want to write? In other words, am I only going to inspect the source IP address, or is it going to be an extended access list? Am I only going to inspect the source destination and the protocol, the service that you want to do? If it's only the source IP address that you want to inspect, then it's a standard list. Then you go to the router that's very close to the source, and that's where you create your access lists. Okay. Otherwise, you just go close to the destination, and that's where you create and apply your extended lists. Okay, just remember when you are writing these entries in the access list, there's an implicit deny at the end, and it's probably a good idea to write, for example, access list 100 deny any. Any means any IP address with any wildcard for the source and the destination. 2 any's when you're doing the extended list, 1 any for the standard list. Now, remember, when there is a match, not a match, when there is a match in the access list, if you're going down the entries in the lag, the security guard and we're checking the entries, once there's a match, either permit or deny, you stop matching. So anything, you stop looking up the list, in other words. You stop looking at the entries below that match. So you got to make sure that you have specific access lists that you want to do first before you go in the list. So for example, if there is a host that in one subnet that you want to deny, and you did in the list, you permitted the subnet first, and then you denied that host later, what's going to happen? That host that you want to deny will always have permission because he was part of that subnet, and that entry went first. So what you should do is deny that host first, then permit the subnet. So you have to be specific first. All right. New ACL statements should be added always. Anytime you create an ACL, especially with the numbered, it always goes to the bottom of the list. So if you want it to go up, you have to specify the sequence numbers that they create. But the sequence numbers are there only when you have named access lists. And the last thing I want to make sure that you know when it comes to the guidelines, any router generated packets, they go in and out of the router without being filtered by the access lists. All right, so here is what I want you to type. I want you to type all of these notes. So right here, all of these, you can pause this, type it in, and the named access list and the guidelines. Okay, so type this one page because that's going to be one of your notes for to submit. Well, there's more coming up in a few minutes. All right, let's go back to the PowerPoint slides. And here's a typical access list, named access list like with deny. So you create the access list by typing IP access dash list standard, and here's the name. This is permit any, because if you don't write this permit any, it's an automatic deny any, right? Here's an extended list, the named access lists, right? This is really typically done for surfing and using the word established, right? Access list surfing. This access list is going to be on the incoming of the G00. This is going to be on the outgoing of G00, the browsing, the one that is established. All right. When it comes to VTYs, so let's say you want to make sure that not only that somebody has the telnet password or the SSH password, but what you want to first do, you want to make sure they are telnetting or SSHing from the right IP address. So this is another layer of security. So what you want to do is you want to create an access list that's going to inspect the IP address of the device that is trying to remote access into the router, and if they match, then you'll check their passwords and allow them to telnet. So that's another layer. Prior to this, you're just checking the password, regardless of where they are telnetting or remote accessing from. But now because if somebody steals your password, most likely they're going to try to remote access from a different device, and this layer of security with this access list will deny them from that. All right, so I do want you to write this down, how to apply an ACL on a VTY. When you create an ACL for the virtual lines, it has to be a standard list because you're only going to inspect the IP address, the source IP address. So you're going to type IP access dash list standard, and you give it a name, and permit this person 192.168.10.10 log means write it down in the logbook, and then you deny everybody else. So that's the list. And now how do you apply this list? By permitting only this person. You go to the line VTY and you say access class. That's what you need to type to apply it. Not IP access group, not access group, access class, and then the name in. And that's it. So please write this down. This is how to apply an ACL to the VTU Online. So now if somebody's trying to telnet, the first thing I'm going to do, I'm going to go to this VTY underscore access, check out his entry. Is he 192.168.10.10? And if the answer is yes, then you prompt them for their password or use username and whatever, depending on how you set up the line VTY. All right. Anybody else that doesn't have the 192.160.10.10 will not be able to remote access, even if they have the password. They're going to be denied before they even are asked for their passwords. All right. Okay, we went over the guidelines. If you want to edit the existing access lists, here's where you actually put the entries in, these sequence numbers, because if you don't, remember, as I said earlier, anytime you create an entry, it's going to go to the bottom of the list. All right. And how do you mitigate attacks? Anti-spoofing. So making sure somebody doesn't use your IP address. So what you need to do on the inbound of the serial port, deny all of these addresses, all of the private IP addresses. So if somebody going from outside and have a private IP address, you're going to deny them because nobody should have a private IP address coming from outside. And deny even the multicasting. You deny everybody from outside that has private IP addresses, and then just permit in the inbound only this any host going out. Okay. Moving on. I'm sorry, not any. Did I say any host? Let me see what that says. Allow the subnet. That's what I meant to say. Going out anywhere. So allowing this whole subnet to leave, but not anybody trying to use a private IP address to come in. Because if they can find out their IP address, they can use a private IP addresses within this network to attack the inside. All right, so how do you permit necessary traffic? Just like we said earlier, this is for DNS, by the way. To allow DNS, you can use the keywords instead of the port numbers, right? By the way, when you get down to here, when you want to say deny any, you have to type the protocol. When you type ICMP protocol, by the way, you're denying all the other ICMP protocols, all the different types of parameters, all the other parameters, all the other keywords in ICMP are not allowed. Only these three are permitted. All the other ICMPs, no matter what you're trying to do, they're not allowed. When you type IP, permit IP any, if you don't write this command on the bottom, all the TCP and UDP will also be denied because there's an implicit denied at the end. So you have to say permit all the others. Okay, so be very careful. Your last command when you're doing extended IP should always be permit IP any if there's any denied. And also, by the way, if you only have denied statements in your list, what's going to happen? Everybody's going to be denied, right? Because the implicit denied will deny everybody else anyway. So if you only have denies and there's an implicit deny, everybody's denied. So when you're creating access lists, there should be at least one permit statement, always. All right. If you want to make sure nobody abuses the SNMP, just disable it. So by typing no SNMP server, that's probably the best way to do. Remember, this is by default, and you want to get rid of. If you remember from last or 2 weeks ago when we covered it in Chapter 2, AutoSecure will take care of this for you. But you should definitely make sure that the SNMP server is not enabled or should not be enabled, or any requests for SNMP traps are not enabled. All right, for when it comes to IPv6, number one, the first thing you need to know, it has to be, there's no numbers with IPv6, it has to be named IP, it has to be a named IP access list. All right, and an example of it is, here's an example. So please write this down too. You want to create an access list called LAN only. You want to permit this public IP address going anywhere, this network. subnet 1, right? Going anywhere. You want to allow the network advertisement and network solicitation by default, otherwise they'll be denied because by default IPv6 wants to be able to send out their network discovery, neighbor discovery, not network discovery, advertisement, and solicitation, so they'll know exactly where they are. So you have to do the ICMP any, and then make sure this is even though you didn't have to write that, but there's a default IPv6 deny at the end. That's pretty much it. When you apply this access list last only, land only, it's pretty much the same way as you would do with IPv4. All right, so let's talk about now the different types of firewall technologies that are out there. Firewalls are resistance to attacks, not wall attacks, although, but as we have seen, we can mitigate some of the attacks. It's like a security guard, right? And there's some limitations to what firewalls can do. Um, if wirelessly they won't be able to block anything, the wirelessly they can bypass the firewall itself if somebody can access the network through a wireless connection. Firewalls generally do not decrypt data, so if you have a VPN set up, they won't be able to decrypt the data. If somebody spoofs your IP address, they'll be able to get in. So there are some specific, um, a massive amount of requests, distributed denial of service attacks can bring down the firewall. So it depends, so that's why you probably want to create a DMZ. But anybody that wants to access public connections for your network, put them in the DMZ. All right, there are four types of firewalls. There's the packet filtering firewall, the application gateway, the stateful, and the net firewall. The net firewall is really just make sure that we can convert your IP address from a public to private and vice versa. But when it comes to packet filtering, it's just a general look at your IP address. This is the standard and the access lists, and that's it. If you match, you're in, and once you're in, you do whatever you need to do. If you're not matched, you're denied, and that's it. There's no keeping of connections. So in general, not a lot of people like to use this. The best and the most widely used is the stateful firewalls, which means when you are going in and you want to leave, to keep an eye on your connection. The, the on these they look at the actual packets reset and your connection that your port numbers, and they write them down before you leave. They know who you are and you're left, and they'll keep an eye on the connections. Are you sending your data to the play? Is your connection going to HTTP and you're still going to HTTP? So keep an eye on it, and when you come back, they'll know that the connection was initiated from the inside. So stateful means it's much better defense. It keeps track. It makes sure this is like a security guard at the front door. And if somebody comes in, just give you an analogy. Somebody comes in, he's a stateless firewall. Somebody comes in and it says, I want to go to the president or Professor G. And they look him up and it says, okay, you're on the list. Professor G is in room 120. So you go to room, and he says, okay, you're allowed because you're on the list. That's stateless. But once you get in, you can almost do whatever you want. You can go to any room, attack anyone. So that's not good. So stateful means, okay, you want to go to Mr. G. So I'll go, okay, you got to go to room 121, but I keep an eye and make sure that you went to room 121. And if you digress and go somewhere else to a different room, I break the connection. So that's why. So stateful is a much more powerful. There is gateway also. Gateway. In fact, not only gateway firewalls up to layer 7, which means not only I'm going to keep track of that you're going to room 121, but I can actually inspect the content of the layer 7, inspect what you have trying to send to room 121. So it's even a little bit more detailed. The next generation firewalls, um, well, here's a list of what they have. They can actually include IPSs now. They even have performance with SPS, I'm sorry, viruses, NAD, VPNs. All right. Stateful benefits and limitations of the firewalls. Please write that down up here because I want you to know, because these are the most widely used type of firewalls that are out there. All right, let's take a look at the classical firewall, just like we have been doing. So what you're going to do is you can create, hardly anybody does this anymore. You can there are 5 steps that you're going to do with the classical firewall. You examine the ACL to determine if SSH requests are permitted, and then you're going to compare, and you're going to do all these, and if there is somebody that comes in, you create an access list, and once it's done, terminated, the router is going to remove the entry from the access list. To be able to set it up, and the way you do it is you create an inspection session. Okay, you create the access list, and then you go to the interface, you apply the access list on the end, and then you can do the inspecting rule on it, on the inside and the outside. Okay. Now, when it comes to inside and outside networks, it makes it a little bit easier to create access lists when you have, a LAN that's connected to the internet. And the best way to do it is to use the ZPF, the zone-based policy access list, which we'll talk about in a few minutes. Let's talk about demilitarized zone, the DMZ zone. Oh, I didn't think we've discussed that earlier. Anytime you have servers that that the public wants to use or have access to, such as your HTTP or e-commerce servers, you want to connect them outside your private LAN through the firewall. So everything will go right here. If there's any attack, it happens in the DMZ zone and not in your private LAN. All right, so that's the best design to really mitigate and make sure your private LAN is all okay. You can actually create another DMZ as a backup. So in case there's an attack, your users will immediately be rerouted to another DMZ zone. You can shut this down and then block the 0-day attacks. So a lot of companies do that. They can never really, but they have to pay extra, you're creating a mirror image of a DMZ. So if you have an e-commerce, you probably want to have another backup DMZ just in case, because if they attack your servers, then you can lose millions and millions of dollars. Anyway, let's continue. Here's the zone-based policy firewalls. To make it easier, you create zones without having to create lists and apply in them and put security guards. And if the list says, okay, you have 2 private LANs that's attached to this firewall, what you're going to do, if they are members of each other, so they can go through without having any inspection. They can talk to each other freely, right? They can send data to each other without any problems. Then you can create and say, hey, if you are from private going out to the internet, you set some rules. You block certain things. If you are a member of either LAN 1 or LAN 2 and trying to get on the internet, you have to follow a certain policy. There's, for example, you can't send emails or whatever. I don't know, whatever the rules are. And if you're trying to get onto if you are a member of LAN 1 and LAN 2 zones and you're trying to get onto DMZ, you'll have certain rules. But if somebody coming from the public zone going into the DMZ will have certain rules, a certain policy that they have to follow, and so on. It's a little bit easier that way, creating zones, and depending on which zone you are a member of, then you apply certain rules. Then individual users and subnets and all of that makes it a lot easier. All right, so this is a little bit more linear defense. The layered defense, you can make sure when you're creating or designing your LAN with firewalls that you take into consideration these these defenses. When it comes to firewall best practices, please write these down. Okay, I want you to write these specific ones. I think most of them are, some of them at least maybe. They're pretty straightforward, self-explanatory, but I want you to write them down so at least you'll review them as part of your notes that you're going to submit. All right, so let's take a look finally at the zone-based policy firewall. So not independent of, they're not independent of ACL, so it has nothing to do. If you have ACLs, it'll still be working. So it has nothing, but it's probably best to just do it for zones, especially if you have a private going to a LAN. Okay, LAN to internet, right? Okay, so here are the steps. Well, before we get to that, ZPF, when you inspect a specific LAN to internet, let's say zone LAN, private LAN to the internet, and if there's a match, you can either inspect, which means if you are going to inspect, the rule is to create a stateful firewall. You either drop the packets from going to the internet, or you can pass them, let them go. This is similar to just regular firewalling. The best to do if you want to permit them is write inspect, create a stateful inspect or drop. Hardly pass is probably not a good idea just to create a regular firewall. Those are the actions that you're going to do when there's a policy between zones. It's either to inspect them, drop them, or pass them. All right, and here are the rules for transfer, either between the self zones or between two different zones. And you can take a look at that. Let's configure a ZPF. Step number one is creating zones. So here's step number one. You create zone security. Please write these down, by the way. So step number one, creating zone, and here's the command. Zone security, and then you give it a name. And then you create another zone security. So this is going to be the private, and this is going to be the public. All right, so I just gave them two names, one private and one public. Second step is you identify the traffic by using the class map type. Okay, and here's the example that you want to do between these two. So write this down. So I want to create a class map type. I want you to inspect any, match any, or by the way, you can match all. So that means all of these have to be matched. If you type match any, if any of these are matched, then you are part of this class. Okay, but then you are a member of this class. If you're trying to do HTTP, HTTPS, or DNS, your packet is coming in, it has HTTP, then you are a member. If it has HTTPS, you are a member. If it has DNS, you are a member. If you are, let's say, telnetting, you are not a member. So forget it, you're gone. You're going to be dropped, right? So all these four different packets are going to be a member. So that's what I'm going to look for matching. What am I going to do when they are with this class map, when they are a member of this HTTP traffic? We'll talk about that in a second. Step number 3, then you got to take the action. You create a policy for the one that are matched. And the command is down here. So you write that down. That's step number 3. You create a policy called priv to public policy. And you say, class type, I want you to inspect this. This policy is going to be looking at the HTTP traffic. That's from step number 2. And if all the members of HTTP traffic, the ones that are matched, I want you to inspect them. So when they are doing HTTP, HTTPS, or DNS, we're going to create a firewall for them, making sure I keep stateful firewall, keeping track of their connection when they are leaving to the internet. Well, we haven't said that they're leaving, right? I just want to create a stateful firewall when there's a match, right? Step number 4, you create a zone pair and a match policy. So a zone pair match policy, here you go. You write this down right here, and then you inspect the private policy. So you write that down, and that means they are going, that's where you're creating the connection, right? And at the end, and then you create then you apply the interfaces. You apply the private to this interface to the serial. I'm sorry, you apply the private to the gigabit, the Ethernet, and the public is applied to the serial 000. Okay. Just want to take a look at something really quick. Excuse me. Oh, good. Okay. And by the way, here, I forgot. Oh, we did the inspect. Otherwise, it would be dropped. Okay, good. I just want to double check that. All right, so this is your fifth step. And ZPF consideration. Um, these are the commands, by the way, to verify and troubleshoot the zone-based policy firewalls. And this is some of the ZPF configuration that you should consider. Please write those down, the ZPF configuration consideration. So this way you'll know. Um, and that's the last thing that I want you to submit. Okay? All right. So until chapter 5, keep up the good work, guys. I'll see you then.